Okay, so starting with cos of A minus cos of B squared. So anything squared is that thing multiplied by itself. So we get cos of A minus cos of B multiplied by cos of A minus cos of B. We're going to break open the first set of brackets, bring down the cos of A, stick on cos of A minus cos of B, bring down the minus cos of B, stick on cos of A minus cos of B. Next we multiply out the brackets. Cos of A multiplied by cos of A is cos squared A. Cos of A multiplied by minus cos of B is minus cos of A cos of B. Minus cos of B multiplied by cos of A is minus cos of B cos A. And minus cos B multiplied by minus cos B is plus cos squared B. We bring down the cos squared A, minus cos of A cos of B, minus cos of B cos of A. So we've got the same thing, but there's two of them, so it's minus 2 cos of A cos of B. And then we bring down the plus cos squared B. And we work this one the exact same way. So sine of A minus sine of B squared becomes sine of A minus sine of B multiplied by sine of A minus sine of B. We break open the first set of brackets, bring down the sine of A, stick on sine of A minus sine of B, bring down the minus sine of B, stick on sine of A minus sine of B. Sine of A multiplied by sine of A is sine squared A. Sine of A multiplied by minus sine of B becomes minus sine of A sine of B. Minus sine of B multiplied by sine of A becomes minus sine of B sine of A. Minus sine of B multiplied by minus sine of B becomes plus sine squared B. Bring down to sine squared A, minus sine of A sine of B, minus sine of B sine of A. There's two of them, so we end up with minus 2 sine of A sine of B, and then bring down to plus sine squared B. Okay, so I'm going to go through it again step by step. So we're trying to prove that cos of A minus B is equal to cos of A cos of B plus sine of A sine of B. So we're going to start by letting P be the point cos of A sine of A and Q be the point cos of B sine of B. These are going to be 2 points on the unit circle whose centre is O, 0, 0. So again, here's our unit circle, centre 0, 0. This is the point P, which is cos of A sine of A, and this is the point Q, which is cos of B sine of B. So we're going to label our points x1, y1, x2, y2, doesn't matter what way you label them, and substitute into the formula. So we're going to use the distance formula from coordinate geometry, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. So we bring down the square root, the x2 becomes cos of A, bring down the minus, the x1 becomes cos of B, and it's squared. Then we have plus, y2 becomes sine of A, bring down the minus, and y1 becomes sine of B, and it's squared. Next, we're going to bring the square root over the other side, and it becomes p squared. So now we have no square root on the right hand side. Then we're going to multiply out cos of A minus cos of B squared to get cos squared A minus 2 cos of A cos of B plus cos squared B. Bring down the plus, and then multiply out sine of A minus sine of B squared, which gives us sine squared A minus 2 sine of A sine of B plus sine squared B. So you can go back to the previous slide to see how I got this step if you need to. So next we're going to group together cos squared A, sine squared A to get cos squared A plus sine squared A. And then group together cos squared B, sine squared B to get cos squared B plus sine squared B. And then factorise minus 2 cos of A cos of B minus 2 sine of A sine of B to get minus 2 cos of A cos of B plus sine of A sine of B. Now again, our trigonometric identity tells us that cos squared A sine squared A gives us 1, and cos squared B sine squared B gives us 1. So we just bring down the minus 2 cos of A cos of B plus sine of A sine of B. So we end up with p squared is equal to 1 plus 1 minus 2 cos of A cos of B plus sine of A sine of B. So next we're going to use the cosine rule on the triangle OPQ. So OPQ. So the cosine rule is a squared equals b squared plus c squared minus 2ab cos of A. Cos of A is going to be the angle we're using. which is in the centre of our triangle, which we are labelling A minus B. Because again, remember this is angle A, and this is angle B, so the angle inside the triangle must be A minus B. So this becomes labelled as A for the purpose of our formula. So then the side opposite that is lowercase a, which is really the side PQ. And then B and C are the other sides, which remember are 1, because they're the radius of the circle. So A squared becomes PQ squared, B squared becomes 1 squared, C squared becomes 1 squared, minus 2AB becomes minus 2 times 1 times 1, and cos of A becomes cos of A minus B. So 1 squared becomes 1, 1 squared becomes 1, minus 2 multiplied by 1 is minus 2, and we just bring down the cos of A minus B. So we have equation 1 and we have equation 2. Both are equal to p squared. So we have p squared equals 1 plus 1 minus 2 cos of A cos of B plus sine of A sine of B. And p squared equals 1 plus 1 minus 2 cos of A minus B. So the 1's will cancel out, and the other 1 will cancel out, and the minus 2 will cancel out. And we're left with cos of A minus B is equal to cos of A cos of B plus sine of A sine of B. So we get cos of A minus B is equal to cos of A cos of B plus sine of A sine of B. And this is what we were asked to prove. So this is the compound angle formula.